Alright, I'm going to do a quick how to solve average atomic mass using the example that I have here, uranium. We're going to look and figure out what the weighted average is of these three isotopes. So there are three isotopes, and they would have to give me the abundance here, and they would have to give me the mass. Now, in the problems that you might be solving, they may not give you the exact mass, they may give you the rounded masses, and you can use that. Your answer is just not going to be as accurate. When you're doing this process, the first thing you need to do is you need to change the abundance from the value given. If it's given in percent, you need to convert it to a decimal, and you're going to do that, sorry, my instructions are kind of off the edge here. You're going to do that by dividing by 100. So you divide by 100. What I'm going to do in this problem is we are going to go ahead and we're going to move the decimal place. We're going to essentially divide this by 100. So this number becomes 0.00 and then our answer that was written there. Okay, and the next one is 0.007204, and then this last one becomes 0.99 and 2742. Remember, when you're dividing by 100, you're moving your decimal places 2 spots to the left. So that's the first step. The second step is you are going to then multiply each line the abundance value, so the value that you have now in the decimal, by the mass. Again, if you have the exact mass, like we do here, use it. If you don't have the exact mass, you're going to use the rounded mass. And we're going to do that line by line. So we're going to take and we're going to multiply these two numbers. Sorry, my pen died. Let's choose a different color. So we're going to multiply those two numbers, and we're going to multiply these two numbers, and we're going to multiply these two numbers, and we're going to get 3 answers. Okay, so using a calculator, because nobody does math in public, you're going to take, slide it down, 0.000054 times 234.040945, and we're going to end up with an answer of 0.012638. We don't need it all. We're just going to write some of the values there. Make sure that you're paying attention and you're not moving your decimal accidentally. So the next line is 0.007204 times 235.043922, and we get 1.693256. And the last one, we're going to take 0.992742 times the 238.050784, and we get 236.32301. Alright, so we have now gotten the portion of the total mass that each one of these isotopes contributes to the total mass, the average atomic mass. This is a weighted average. If you're doing a weighted grade, you do the same thing category by category using the percents. So we've taken the abundance of the 234 times its mass, the abundance of the 235 times its mass, the abundance of the 238 times its mass, and now the last step is we are going to add all our values. Now this example has 3 isotopes. Some examples that you may encounter would have more than 3. Sometimes they have 2, sometimes they have a whole bunch more. Whatever it is, you're going to add all the values. So I happen to have the 236 point, my last answer here. I'm just going to add these other two numbers, 1.693256 and the 0.012638, and I'm going to get 238.0289. That's enough. And this is in atomic mass units, or sometimes it's represented in grams. And so if you look on the periodic table, the mass of uranium on the periodic table behind me is 238.029. And hopefully, if we did our process right, the value from the periodic table equals the average atomic mass that we calculated. And basically what it's saying is that in nature, 100 particles of uranium we would have 99.27 would be the 238, 0.72 would be the 235, and 0.0054 would be the 234, and we're considering all of them to calculate our average atomic mass. 3 steps, do them line by line depending on what information they give you, and you get your end answer, which is the 238.0289.